Okay, now we move to the traverse function and display list. It is to traverse item in the list from beginning to the end. It needs a pointer to move from one node to another node. So that means it wants a pointer that moves from the first node until the last node. So the pointer, we can name it as a traverse pointer. Start with point to the hit node, and it will keep moving until it becomes null. So it becomes null, that means at the last node. Okay, so how are we going to do this? First, we need to set the traverse pointer to the first node. So now hit pointer points to the first node. To traverse the list, we need to point the traverse pointer points to the first node. So whatever hit pointer points at, ptraverse also points at. So we create a pointer of type node and get a value as same as the hit pointer. Okay, so hit pointer holds the address of the first node. So whatever hit pointer holds, ptraverse takes that value, and it means that ptraverse will also points to the first node. Okay, now we want to move this ptraverse from first node to the second node until the end of the node. How are we going to do that? We use while loop. Okay, so while loop check the condition whether ptraverse equals to null, not equals to null. Yes, it is not equal to null because ptraverse points to the first node. There's a node that ptraverse points at. So if there is a node, then it will enter a while loop and display the ptraverse data. What is the ptraverse data value? 21. So it will display 21. And then it will move ptraverse, move to the next node. How are you going to do that? By take the value of ptraverse link. So previously, ptraverse link points to this node. So whatever ptraverse link points at, ptraverse also points at. So it will move to the second node. So because ptraverse takes the value of ptraverse link, and ptraverse link has the address value of this node, and that's why the ptraverse pointer points to the node equivalent to the ptraverse link. Okay, now if we continue the loop and check whether ptraverse not equal to null, no, it has a node that ptraverse points at. So the condition is true, and then it will print the traverse data 35. Okay, then we continue to move the ptraverse equal to ptraverse link, and move the ptraverse pointer, move to the next node, and then check the while loop again whether ptraverse not equal to null. Yes, true, because ptraverse points to a node, and then the condition is true. Enter the while loop, and it will display the ptraverse data. Now the ptraverse data is 54. It will print 54. Now we move to ptraverse to the next link. The next link is null. So whatever with ptraverse links points at, it points to null. Ptraverse also points to null. Okay, now check the condition. Is it ptraverse not equal to null? False. So it will exit the loop. Exit the loop, and then that means ptraverse is already moved from first node until the last node, and it already display all the value inside the list. Okay, now we move into a delete item function. It is to remove node from list. They have two ways: whether you want to delete the only node in the list, or you want to delete the first node. That will be the special case, because it needs a hit pointer. And the second case is that the delete last node or middle node in the list. That will be the general case. Okay, now to delete the only node or first node in the list, these are the steps to be taken. First, you need to set the p temporary, which is pointer temp, temporary pointer to point to the head node and set the same head point with the temporary node, and delete the temporary pointer, and you decrease number of items. So we need to follow these steps. Let's say we want to delete the only node or first node. That means you want to delete the first node in the list, 21. So head pointer points to 21, 21 points to 35, 35 points to 54, 54 points to null. There are 3 items here, 1, 2, 3, 3 nodes. Okay. Now you want to delete this. First, you need to set the temporary pointer points to the first node. So whatever head pointer points at, ptemp also points at. Okay. And then we want to delete this. Before we want to delete this, we want to make sure that this head pointer points to the next node. Okay. So head pointer equals to ptemp link. Okay. And then we can delete this ptemp, and then we decrease the number of items equals to 1, and by 1, and it becomes 2. So now p head points to the second node, and this second node becomes the first node. Okay, so 35 and 54 will be the only node inside the list. Okay, right. How are you going to delete the last node or middle node in the list? These are the 5 steps taken. Okay, first you need to set the pointer points to the node that is going to be deleted. Then you need to have a before pointer points to the previous node that is going to be deleted. And then you need to set the before node link path same as a temporary node link path. Delete the temp and decrease the number of items. So how is it going to do that? Let's say we're going to delete the middle node, or we're going to delete the last node. The same algorithm. So delete the 35. We need to make the ptemp equals to phead, and we need to move the ptemp until the nodes that we're going to delete. Alright, so ptemp start with head, and we move the ptemp head, the ptemp pointer, and with this condition while loop. Okay, is it ptemp not equals to null and ptemp data not equals to target? True, then it will set a p before item equals to ptemp, and ptemp move to the next link, and continue the while loop. And continue the while loop. Is it ptemp not equals to null and ptemp data not equals to target? False. So it will exit the loop, and then we need to put the p before link to the ptemp link. So we need to remove the ptemp. Whatever ptemp points at, we need to delete that node. So before we delete that node, we need to establish the link. So p before is required to establish the link. So p before link equals to whatever ptemp link points at. So now we can delete this ptemp link, and then left the p before with the p before nodes with the last node, and we reduce the number of items equals to 2. Alright, that's it.